Welcome back to Advent of Code 2015. We're on to day 23. Hello, Maro. Let's finish this. We'll see. um, it all depends on how long these last couple take. It's definitely possible, though. I mean, realistically, every problem in these lists, if I understand which algorithm we're using here, I could probably do it in half an hour. It just takes longer if I get stuck, but all right, so let's begin. '23. Opening the Turing lock. Hang on. Okay. Little Jane Marie just got her very first computer for Christmas from some unknown benefactor. It comes with instructions and an example program, but the computer itself seems to be malfunctioning. She's curious what the program does and would like you to help her run it. Oh, it looks like a kind of shift register problem. They can be interesting. They can be difficult though. Alright. The manual explains that the computer supports 2 registers and 6 instructions. Okay. Truly, it goes on to remind the reader a state-of-the-art technology. Okay. The registers are named A and B and can hold any non-negative integer and begin with a value of 0. The instructions are as follows. Alright. Half R halves the number. Okay. Triples it. Inc increases it by 1. Jump offset is a jump. Continue. So you jump a certain number of instructions away from itself. Okay. G R offset. There's actually a comma here. Okay. Weird. Alright. It's like jump, but only jumps if register R is even. Jump if even, jump if odd. Okay. All 3 jump instructions work with an offset relative to that instruction. The offset is always written with a prefix plus or minus to indicate the direction of the jump. Jump plus 0 would continuously jump back to itself forever. Okay. The program exits when it tries to run an instruction beyond the ones defined. For example, this program sets A to 2. So we inc A to 1. If odd, if A is odd, then we go to plus 2. Inc A. And then we are out of instructions. Okay. Interesting. What is the value of register B when the program in your puzzle input is finished executing? So this doesn't look hard. I think you just do it exactly as they've described it. It's not even that many instructions. You just follow the steps. There's no tricks to this, I think. No clever kind of reductions you need to make. Okay. If we just code it exactly correct, it should just work. So let's do that then. Okay, so let me copy the input in. Okay, so we just make a list of instructions. Okay, so hello, Sand Knight. Good morning. Question mark. Well, the question mark is appropriate because it's 7:30 p.m. for me. Let me just drop a link here. This is the problem. I just started. Almost exactly opposite of the Earth. I do tend to be the opposite of Earth from you guys, like the antipodal point, to be geometrically precise. It's always 12 hours apart when we were organizing those Azure Dreams tournaments and stuff. So this problem looks easy. I think it will only take me 20 minutes or so. I don't think part 2 can even be that complex. Alright, so start by just getting all the inputs. Let's just copy some old code here. When was the last time we read the input? Okay, here. So let me zoom in a bit. Okay. Alright, so instructions is just an empty list. Just put the, let's say, line.strip.split. So that will just split it into tokens. Now, it's kind of weird that they have a comma after the A here, but whatever, we'll just have to cut it off. Well, we can actually do a replace here. Dot replace comma with empty string, because I don't, that comma is just making things more confusing. Alright, so now we'll have tokenized it, so we'll have a list of tuples which will have these things in. Alright, that's easy. And now there's an A and there's a B. Alright, so A, B equals 0, 0. Instruction number equals 0. While... So they said if you try to access an instruction that doesn't exist. So do they also mean it could be a negative instruction, like something like -10? Maybe. All right, we'll assume that could be. So say while 0 is less than or equal to so we just keep going until the program counter, instruction counter. Actually, I like that phrase better. Let's call it instruction counter. Goes out of bounds. So we start with 0. So instruction equals we fetch the current instruction, and now we just do a big if else. So if instruction equals, let's start with this, let's go in the order they specify on the website. Half, okay. Half. Okay, let's just organize this like this. Register equals A has value 0. No. A is value 0. B is value 0. That's a better way of doing it. So I assume they're rounding down. So it would be register use the second parameter to view into the dictionary. Divide by 2. Then ints counter increment by 1, and then go back into the loop. And then just do this for every command. So what are the other commands we've got? Triple. That's even easier. All right. Ink. That's the easiest of all. Okay. Jump offset. So if it's jump, then we don't change anything in the register. We just say instruction counter will increment by the integer value of the next parameter, and it has the plus or the minus there, so that's straightforward. Jump if even. So if register using the second parameter percent, so it's to check if it's even, %2 is 0. Then we increment the counter by that. Otherwise, oops. This could be written more compactly. At this point, it doesn't matter. Otherwise, just increment by 1. So increment by 1 or that, depending on whether it's even or odd. All right. We don't even need all these continues. It will continue anyway. So if it's odd, we do that. Otherwise, we increment by 1. Let's just get rid of all the continues. All right. And then what is the actual question we wanted to... what is the value in register B? All right. Let's just print the register fully. And run. Instruction... Oops. How? Oh, why did I do that? Instruction. Oh, okay. Just need to replace all of these with put the brackets the wrong way around. All right, instruction counter plus equal int. That should be a 2. It's the third parameter I'll be using for that one. All right, A is 4591, B is 0. That doesn't look right. B is not going to be 0, is it? I'm not going to submit that yet. So we never hit B, and we got A to be 4591. I mean, we can easily follow this by hand. But the question is, does it ever hit B? And the only time B ever gets changed is this line here. So do we ever reach this line? Interesting. So from here, the only way we can get to 39 is either coming from 38 or coming from 16. That's the only two possible ways. So here, we would jump ahead if A is odd. So if A is even, we would go here. So will we ever get to a situation where we get here, A is even? Probably, I don't know. If we don't, then we go to A is odd, we go 1, 2, 3, 4, 5, 6, 7, 8. We finish the program. Well, that's weird. Hang on. Let's run this again. Let me just have a look at the instructions, make sure these look right. Hang on, I'm not sure that I'm using the indices correctly for the instructions. I have to read again what they... So those are the instructions. Yeah, okay. Let's have a look. Program exit when it tries to run an instruction beyond the ones defined. +1. Alright, yeah, okay. I think what I've done is correct. Could it actually be 0? Because this is saying if A is odd, finish the program, because there's no +8 instruction. It goes to out of bounds. So, and if it's A is even, inc B. One, 2, 3, 4, and then we go to A, and then we halve A, and then we jump 1, 2, 3, 4, 5, 6, 7 when we go back here. So basically, this keeps halving A until it's even. Wait, what? Should we just try B as 0? I don't think it's correct though. Like, it can't, like, surely it would be... If odd, plus equal int instruction 2. I don't know, it all looks correct. Jump becomes a plus equal instruction 1. I just have to try it, get it over and done with. All right. B is 0? No, it's not right. It couldn't be right. Like, they wouldn't leave it at 0, but it's a very strange input because it does... No, I thought I made a mistake with the ink. No, that's right. I did it correctly. I mean, this is a very easy set of instructions, so I've probably done something very... Oh! That is so sneaky. Look at this line here. Oh, he did that on purpose. He knew we would just skim read these. He did that to troll the speed coders who just skim read them and quickly write a program because, you know, they're competing. You got jump if even, jump if 1. Alright, so we need to change that to if register R is 1, not odd. Alright, jump if 1. So if register instruction 1 equals 1, we jump. Otherwise, increase counter. Let's try that. B is 170, A is 1. And that makes sense, because A would have to be 1 to go into B. 170. Correct. Okay. Part 2. The unknown benefactor is very thankful for release, helping little Jane Marie with her computer. Definitely not to distract you. What is the value in register B after the program is finished executing if register A starts as 1 instead? Just change A to 1. Could there be anything difficult here? Is it going to be in an infinite loop or something? Nah, because then there'll be no answer. So let's organize this. I want to make this cleaner though. So let's say define run instructions. That. So part 1. Just yeah, go like this. We don't need instruction counter will start at 0. Alright, so we do run-ins like that, print register. So that's should give us the same answer. Oops, not debug. Yeah, okay, and now part 2. We change the register to be a equals 1. And then just do it again. That shouldn't keep any... Yeah, that's fine. 247? Correct. That was the single easiest part 2 so far. Seriously, it literally changes 0 to a 1. But there could not be a simpler change. That's the simplest possible. Right. We're on to 24. It's Christmas Eve. What do people do on Christmas Eve? I think I don't know, in the UK normally it was tradition to eat fish on Christmas Eve and then turkey on Christmas Day. I think in Eastern Europe they actually celebrate Christmas on Christmas Eve fully. Have you been naughty? We'll find out. It hangs in the balance. It's Christmas Eve. Santa's loading up the sleigh for this year's deliveries. However, there's one small problem. He can't get the sleigh to balance. If it isn't balanced, he can't defy physics and nobody gets presents this year. No pressure. We do in Quebec celebrate 24th evening. Oh, really? Okay. Santa's provided you a list of the weights giving gifts at midnight. Yeah, that's similar to... like we used to celebrate Christmas with like my Polish side of the family, and yeah, they would do it exactly like that. Like celebrate Christmas on Christmas Eve and do the present stuff like late at night in the evening. Packages need to be split into 3 groups of exactly the same weight. Ooh, is this a knapsack problem? And every package has to fit. So you need to make the 3 groups equal. Okay. The first group goes in the passenger compartment of the sleigh, second and third go in containers on each side. Only when all 3 groups weigh exactly the same amount will the sleigh be able to fly. You'd have thought you need just the left and right be equal, but apparently you need all 3. Defying physics has rules, you know. Of course, that's not the only problem. The first group, the one going into the passenger compartment, needs as few packages as possible so that Santa has some legroom left over. It doesn't matter how many packages are in either of the other 2 groups, so as long as all the groups weigh the same. Furthermore, Santa tells you, if there are multiple ways to arrange the packages such that the fewest possible are in the first group, you need to choose the way where the first group has the smallest quantum entanglement to reduce the chance of any complications. The quantum entanglement of a group of packages, oh my god, is the product of their weights. That is the value you get when you multiply their weights together. Only consider quantum entanglement if the first group... Okay, fine, that's the tiebreaker. There's multiple layers of tie-breaking here. We need all 3 groups to be the same weight, and of those we need to pick the grouping for which the middle grouping is of smallest number of packages, and of those we need to pick the ones such that the product of the weights of the inner group is minimal. I assume there's no more ties after that. Suppose you have 10 packages with weights 1 through 5 and 7 through 11. For this situation, some of the unique first groups that quantum... Alright. Let's have a look. So we've got weights 1 to 5 and 7 to 11. So if you put like 11 and 9 here, and 10, 8, 2 here, and 7, 5, 4, 3, 1 here, the product of group 1, which is the middle one, is 99. And we've also that's also the minimal number of items in group 1. So that is the optimal, isn't it? No. Yeah. Yeah, they're saying that that one wins because it's the smallest number of packages. Don't have to answer this, but you said you had Polish family on one side. What is the other one? English? Kind of a mix of Indian, Portuguese, and Kenyan. Just that side of the that side of the family just were part of colonies around the world. So, in general, Portuguese mostly, I would say, but probably long way back originated from India. So they're asking, the actual number we want to give here is the quantum entanglement of the colorful history. Yeah, it sure is. Yeah, I have a hand in every country pretty much. So we want the quantum entanglement. Okay. I mean, there is a clear brute force method here. It's just a question of whether brute force will work. Brute force is to just try every grouping. Wait, how big is the input? That's what's important here. Not too big. How many is this? Let me copy it into... That is 29 elements. And the number of possible group 1s, like excluding the fact you then need to pick group 2 and group 3, number of possible group 1s is 2 to the power of 29, because every item is either there or not. So 2 to the 29, and that's not too big, is it? That is too big. Yeah, that's almost 1 billion. Alright, fine. But I mean, most of those we don't need to use because we are optimizing on the size of group 1. Like, you would never pick a group 1 which is bigger than 50%, because if you did, then group 2 and group 3 would be the group 1, not group 1. So you never really need to go more than a third, because if you pick 3 groups, the smallest of those groups is always going to be less than a third. That's just like pigeonhole principle. So if we say change this to 2 to the power 10 instead of 29, that's more like it. 1024. So there's basically 1024 group 1s we can pick. And then once we've picked group 1, you can pick group 2 and 3. Doesn't matter what you pick for... Oh, no, it does. Hang on. So it doesn't matter how you arrange group 2 and 3, as long as there is some arrangement which makes their sizes equal. You don't have to try all the possible groupings of group 2 and 3. You just need to pick group 1. You need to know if it's possible to split 2 and 3. Interesting. Yeah, I think this is brute force. It looks like the numbers are small enough that we can just brute force it. Just try all group ones. For each such, check if there is a split for 2 and 3. We don't need to execute it, we just need to know if it can be done. And if it can, then we just say, okay, just work out the quantum entanglement and the size, record the best one we've seen so far, and that's it. So it's 1024 different group ones. And then to test whether it can be split, I guess it'll be another, at worst, another 1,000. So overall, it's going to be fewer than 1 million different trials. So that's doable. Okay, let's do it. $24. Okay. Packages equals list. Packages dot append int line. So we've got our packages, that. Now, this is where we can use ITER tools. No, it's from ITER tools. Import combinations. Yeah. So also, we can start with group 1, size 1, then 2, then 3, and as soon as we find a valid group, we've already found the optimum number of packages in group 1. We don't need to go to the next R. So that's okay. This may be your chance to use group by. I don't think so, because I don't really want to group 2 and 3, only 1. So the only thing I want to do here is pick out a group of size R from this list and nothing more. Using group by would kind of use more calculations than necessary, because it would also iterate over the different group 2s and 3s. I don't care about group 2 and 3. They don't matter as long as it's possible to make them even to each other. So yeah, I can cut out a lot of computation by just focusing on group 1. So we want to do for R in range starting from size 1. And as I said, we don't want to go beyond length of packages divided by 3, because there's no reason you'd have a group that's larger than the average. Because if you did, then one of the other groups would be smaller than the average. Okay, so not that it matters. We're going to stop as soon as we find something. Okay. So then we do for group 1 in combinations of packages length R that's it. Let me just print this. I want to see that it's doing it. It'll go on a long time, but actually it won't. It'll be like a few thousand on it. So it should actually terminate. Around, oh no, it might actually go on a long time, yeah, because we're going to like 10. That's fine. Okay, so that looks correct. All right. What is the total? Total equals sum of packages, and that must be divisible by 3, otherwise the problem's impossible. So if sum of group 1 is not equal to total divided by 3, let's print the total as well. I want to know. Then skip that one. That should cut out a huge number of permutations. Yeah, it's there we go. That's all of the ones which do sum to. Let me just see what we've got here. 1536 is the sum of that. What's 1536 divided by 3? 512. We want each group to add up to 512. Okay, so far so good. Now what? So we've got a group. It's summed to the correct amount. The last thing we need to do is now we need to observe what's left and see if it can be split evenly, which we can just do another combinations thing. That's probably won't take too long, but it will add a bit of complexity here. Okay, so remainder what is the cleanest way of doing this? We can say remainder is just a list for P in packages. These groups will be small. We don't need to use a hash set or anything here. We can just say for P in packages, if P not in, or we can just use this. Let's just do this. Remainder equals, we can use set difference. And this is actually efficient. Set of packages minus set group 1. I believe minus there uses set difference. We can double check that if something doesn't seem to work. So that's the remainder. We probably want it as a list. And we can cut out some computation here. Instead of creating this set over and over again, we can just make packages a set to begin with. And that will work with packages, and now we don't need to cast it to a set over and over again, so that just avoids doing that. Okay, just make sure we're actually getting stuff. Print group 1 and the remainder. Let's see if they make sense. Stop. Okay, that looks right, yeah. Okay, now what? We want to find out if the remainder can be aligned. So we want to say we don't need to cast this to a list anyway. We've now got a set, or we can say for group 2 in combinations right, we need a new iterator size here. Let's say k equals length group 1. I mean, group 2 is never going to be smaller than group 1, otherwise group 2 should have been group 1 in the first place. So we can start from group 1's size and increase from there. So for group 2 in combinations, right, so we go for k in range, change this to start from length group 1 and finish at length remainder half that. You never want to go beyond that. So for each value of k, for each group 2 of size k, we want to say let's just take this calculation out here. Group weight equals total over 3. Whoops. And just stop summing that there. All right. Let's say, well, we're trying to find out if there is a way to balance this. So can balance equals false. All right. If some group 2 is group weight, can balance equals true, and immediately break out of this loop. We're done with all these calculations. If can balance here, what we also want to break. All right, so at this point, we've determined whether group 2 or group 3 can be balanced. So at this point, we've found a valid group 1. The only thing left to do is... Okay, so we've concluded that for r equals, I don't know, 5 or whatever that we're sitting on, it's possible to make a group 1, which will be the correct answer. But there might still be other groups of size 5 which have lower quantum entanglement, so we still have to stick to that value of... Oh, yeah, so we still have to complete this for loop. But we don't have to move on to the next R. So how do I express that? We just want a Boolean saying... So we want best quantum entanglement. We're trying to minimize it, right? Smallest, yeah. So equals just something massive. Let's say that. I don't know. Would that be bigger than the realistic product? You want to avoid spooky action at a distance. I don't get it. Avoid spooky action at a distance? Is that something related to quantum entanglement? Let's just make this a huge number. Okay, so if we have got this far, if can balance, no, if not can balance, we go to the next group. So if we got this far, we have a valid group. So quantum entanglement equals one for x in group 1 QE Yeah, because Einstein said that even if entanglement is a thing and two particles are entangled together, information should not be able to travel faster than the speed of light. Oh, right, yeah, okay, yeah, that's true. Yeah, because it's the speed of light is essentially the speed of information. So, yeah, there's no way you can transmit information from one place to another place by any means. Which is interesting, because then if you do thought experiments, like if you had a really long stick, which is, you know, really, really, really long, you'd have thought if you just push that stick, then whoever is at the other end of the stick would see it move, you know, and then you would think that you could transmit information that way. But I think by this law you can't, so I don't know what happens in that scenario. I think the stick compresses and the information's the atoms move kind of in a slow way, such that they don't actually, the stick doesn't move in a way such that the other end of the stick moves simultaneously with the first one. It actually moves at a delayed time, something like that. Yeah, and it's also the reason we can't have zero latency when playing video games with each other. if some of us are in Vietnam and others are in Canada. Better to stick to turn-based games. Turn-based combat. Best QE Turn-based is fun. It's no skin off my nose. Oh yeah, definitely. I'm way more into turn-based games nowadays. The only real-time games I would probably play are shooters. I still have a fondness for like some shooters, but yeah, turn-based comp. If it's ever a strategy game, it's got to be turn-based for me. I can't. I played because Age of Empires 4 went free to play for like a weekend a few weeks back, and I played it and I enjoyed it, but I was like, I really need turn-based. I can't process all this real-time like stuff, and you have to think really fast on the spot for Age of Empires because it's pretty chaotic. It's really fun though, but I just can't see myself ever competing in Age of Empires. I would only ever play it for fun. Alright, so we've got the best QE. Alright, so after we've tried all these groups, if best QE is strictly less than whatever we set it to be to begin with, then we can actually say we don't need to go to the next R, so we can actually break, because there cannot be a better group now, because we prioritize the size of the group. So we'll break out of this R loop. All right, at this point, I think this is all the correct logic. Something might be wrong in there somewhere, but we can try to debug it. And then finally, we want to print best QE. I don't know if I've set QE, the initial QE, to be large enough. We'll see. 512. No, that's the size. So now we are ranging through... Ah, there we go. So it took a few seconds, but I mean, I have lots of shortcuts here, like escape early conditions, which is good. That cuts out a lot of the calculations. See, this is why you've got to use Python for this type of problem, because if you use C++ or something, then you have to deal with 32-bit integers, and I don't think, yeah, this number is too big, so you have to write your own. Either you write your own integer, which is long, or you use the long ints or something. I don't know. Python, you can have unlimited size integers. That's the beauty of Python. I don't even know how many other languages support that. A lot of them don't, because it's, you know, in theory it's slow, but it's fast enough for these types of problems. Whoops. Okay, I need to switch to... Alright, this is the kind of problem where if you get an answer, I feel like it must be correct, because getting an answer in the first place is kind of... Oh no, there's a couple of things I could have done wrong with grouping though, but let's see. Yes, correct. That's weird. The sleigh still isn't balancing. Ho ho ho, Santa muses to himself. I forgot the trunk. Do they use the word trunk in North America? I think it's very much a British thing, isn't it? Wait, don't they call it the boot? Or have I got that the other way around? What do we call it? No, we call it the boot. The Americans call it the trunk. Yeah, it is an American thing, isn't it? No, yeah, in the UK we call it the boot. The boot of the car. The hood and the boot. We have boot sales, where it's like a garage sale. Like they have garage sales in the US, but in the UK we call them boot sales, because everyone turns up with their car, takes all the stuff out of their boot, puts it on a table, and then sells all their stuff at the boot sale. We don't have garage sales because we don't really, our houses aren't organized in such a way that garage sales work, I don't think. Maybe some areas do have garage sales, but we don't really have those styles of front lawns often, so. We do say hood though. Yeah, I think, no, we don't say hood in England. We say bonnet. I think. Yeah, bonnet. But I wouldn't be surprised if everyone says hood nowadays. And there's like a phrase, be in your bonnet. I don't think it means be in your car though. I think it means be in your bonnet. Like a bonnet is something you wear if you were born in the Victorian times or something. Yeah, it's a French word. Yeah, so it's a bee in your bonnet means something's bothering you. Okay, they want us to balance the sleigh again, but this time separate the packages into 4 groups instead of 3. Bonnet, yeah, bonnet. Given the example. Okay, it's sort of easier and sort of harder, this condition. Well, it's harder to code, but it might be quicker to run, because when you separate the packages into 4 groups, it means they have to be smaller, and then there's fewer to check, sort of. Of these, there are 3 arrangements that put the minimum. It's probably at this point I would want to use group by, except I only have to add 1 more level here, so I don't really need to. I could just add that 1 more level. So, yeah, I just need to adjust what I have before, but I need to say, my favorite UK expression is "Who got your knickers in a twist?" here. Knickers. It's not a word we often use anymore, but yeah, back in the day, knickers would be a lady's underwear. Now it's just pants, panties. So I think part 2, I just want to copy all that and adjust it. So okay, just copy all of this. So total is sum of packages, group weight is right of 4 instead of 3. So it was 5. Hang on. So the group weight we want now is 384 instead of 512. Okay. So best QE, okay, so we keep all this the same. We want length of packages divided by 4. For group 1 in combinations packages. If it's not the group weight, continue. Remainder is the pack. Okay, we've got the remainder. Now the cam balance bit is a bit trickier, so either we just do kind of 2 layers of this, which we probably can. Might as well just continue into this next layer, because they're not going to make us do it to another layer. This is part 2. All right, so here we need to change this. So we've got a group 2, which matches the group weight. We've got a group 1, which matches the group weight. The last thing we need to check is whether group 3 and group 4 can be arranged. It's a group weight, because that would... Let's just look at this again. 4 groups instead of 3. Yeah, that's right. But at this point, it probably would have made sense to go back to the beginning and just divide it in 4 groups to begin with. Oh, 3 groups, even with a... no, 4 groups. But anyway, so here, I want to say... So we've got a group 2. Now, check if remainder can be evenly split. So, let's just call this remainder 2 equals packages minus set group 1 plus set group 2. Oops. All right. And then we want to do basically this loop again. For, let's say, J in range. Let's say, starting from length group 1, because it has to be, can't be bigger, can't be smaller. Length of remainder. Okay, that's got to be 3, because we're dividing this into 3 groups, and now we're dividing into 2 groups. For group 3, in combinations, okay, remember to use remainder 2 of size J. If sum group 3 equals group weight, at this point, we say can balance equals true and break out. Now that will break out of this for loop. If can balance. Now the better way to do this would have been to make a method, separate method. That way, instead of having all these can balance flags, we can just return here, and I'll break out of all these inner for loops. I'll just keep going the way I've done it. Break out of that. If can balance break. We had to write it multiple times. This is messy. If can balance break. Every for loop is saying if we can balance, then break out of this. Fine. I'm not sure if this is going to work. I feel like... Okay, just try it. I feel like some of this looks a bit wonky. Set plus set. Unsupported operand type. Oh, it's vertical line. Or union. That's what it says the answer is. Correct. Okay, yeah. I didn't feel. I mean, in principle, there was nothing wrong with that code. It's just it feels when you have that many for loops, it's so easy for it to go wrong. But as I said, it would be better if I made that as a separate method. That way, the moment I find a group structure which works, we can do return true, and then I don't have to keep checking in every for loop if that's the way you're supposed to do it. All right, so that was an interesting problem. So we've reached Christmas Day. Oops. So yeah, Christmas Day, traditionally the hardest we programmers have to work out of all our family, because we're the ones doing advent of code while everyone else is having a holiday. So there should only be a part 1, and part 2 will just say now you have to go back and get all the stars you've missed, and that's your part 2. So part 1, let it snow. Alright, let me just... Alright, let it snow. Merry Christmas! Santa is booting up his weather machine. Looks like you might get a white Christmas after all. What is they referring us to day 1? Oh, right, okay. The whole point, the whole storyline here is that Santa has a weather machine to make it snow, but he needs 50 stars to power it. I forgot about that. Okay. The weather machine beeps. On the console of the machine is a copy protection message asking you to enter a code from the instruction manual. It's referring to that old thing. It's quite funny. I remember playing games like Prince of Persia, where I would get to level 2. Prince of Persia had a mean one, because I had a legitimate copy of the game, but I didn't have the instruction manual. So every time I would have to replay Prince of Persia, you would get to level 2, and just before you start level 2, you're put in this room where there's like a bunch of potions on the floor with a symbol under each one, and it says on page so-and-so, word so-and-so, or it says there's some mechanism by which the manual will tell you which potion is safe to drink. And you have to use the instruction manual to know that. And because I didn't have the manual, I just had to guess every time. So my process of playing Prince of Persia was literally to keep doing level 1 over and over again, which is quite hard. Level 1 was really hard in Prince of Persia. And then I would have to guess, and either I die and have to start again, or yeah, lots of games did that. I really liked. I thought Prince of Persia's way of doing it was quite funny. It's just really mean if you didn't actually have the manual, and I didn't. Like, because, you know, I often got games secondhand, like from boot sales or from other people who were giving us their computer or whatever. Yeah, Indiana Jones had one as well, but it was nasty because they always did it after you did the prologue or the first level. And Metal Gear Solid had a really nasty one as well, because that was a PS1 game, and at some point in the game you have in the story of the game you find a CD, and it's like you have to use something that's written on the CD cover. And so in the game you bring up the item inventory and you look at the cover and you rotate it and you can't actually see what's written, and then you have to have a light bulb moment to realize they're actually referring to the real life game. And so you're supposed to take your real life disc cover and look at it, and you're like, oh well, a very meta thing. But a lot of people didn't realize they're referring to the real life game and not the in-game game, because there is a game in-game that you can look at. Right, I'm going way off topic here. Yeah, Metal Gear was a very meta game in general. That's the one that actually points out you play as a Dreams, isn't it? It was the very first game. Or was it the second one? I think it was the first one. Okay, so apparently it refuses to run unless you give it that code. No problem. You'll just look up the code in the Ho, 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 Santa ponders aloud. I can't seem to find the manual. You look up the support number for the manufacturer and give them a call. Good thing, too, that 49th star wasn't going to earn itself. Oh, that machine is quite old, they tell you. That model went out of support 6 minutes ago, and we just finished shredding all of the manuals. I bet we can find you the code generation algorithm, though. After putting you on hold for 20 minutes, your call is very important to them, it reminded you repeatedly. They finally find an engineer that remembers how the code system works. The codes are printed on an infinite sheet of paper, starting in the top left corner. The codes are filled in by diagonals, starting in with the first row with an empty first box. The codes are filled in diagonally up and to the right. This process repeats until the infinite paper is covered. Cantor's diagonal argument, very important argument in mathematics. So the first few codes are filled in this order. I see. So you start with 1, then you go 2, 3, you go 4, 5, 6, 7, 8, 9, 10, and so on, infinitely. Alright. Is this like the triangular numbers or something? I recognize this sequence. What do triangular numbers look like? 0, 1, 3, 6, 10, 15, 21. It is. Well, that first row is the triangular numbers, and then the next row, I guess, will be some variation of triangular numbers. This is the process by which triangular numbers is computed, I suppose. Yeah. Alright. So, for example, the 12th code would be written to row 4, column 2. The 15th would be written to row 1, column 5. Okay, fine. The voice on the other end of the phone continues with how the codes are actually generated. The first code is that. After that, each code is generated by taking the previous one, multiplying it by that number, then keeping the remainder from dividing that value by that number. Okay. Wait, where does the paper come into this? So to find the second code, there's more to this, hang on. The first code is, well, it's 2015, 25th of November? Okay, interesting. All right. Alright, I understand this bit, but where does this paper come into this? Okay, so to find the second code, which ends up in row 2, column 1. Oh! You're not putting these numbers, 1, 2, 3, into this triangle. You're putting these codes in. So you're putting this in this position, and then you're putting the next code into this position, and then you multiply by that to get that, divide by that to get that. That is code 3, and that goes here, and so on. And then the machine is going to say, I want to know what's in row X, column Y, or whatever, something like that. Okay. It looks like we missed a scrap from one of the manuals. Let me read it to you. You write down his numbers. So that is that process, essentially. We don't see what some of these diagonals are holding. Now remember, the voice continues, that's not even all of the first few numbers. For example, you're missing the one at 7-1. That would come before 6-2. But it should be enough to let your... Oh, it's time for lunch. Bye. The call disconnects. Santa looks nervous. Your puzzle input contains the message on the machine's console. What code do you give the machine? To continue, please consult the code grid in the manual. Enter the code at row 2981, column 3075. Oh my god. Okay, my initial thought was that might be really scary, but that's not too bad because this process, taking one code and getting the next one, this is very fast. Like multiplying by that number and then doing the remainder, this is arithmetic operations, that's fine. So it's basically instant. So you basically have to fill a matrix of like roughly that number times that number, which is about a few million. That's fine. We can do that if we do this process. So we can do brute force here. I don't think we have to be smart and find some trick to working out what number somewhere deep into the matrix is without computing all the previous ones. I think we can just do this process. It's just a bit ugly, but whatever. We don't even have to use this. We could just use that number and just compute it all ourselves and see if it matches. I don't think I'll try this one by hand. I mean, if I was a kid and I was playing Prince of Persia or something and I was stuck, I probably would try to. But yeah, no, that's a few million. That's probably too much even by hand. But it could be done with a spreadsheet. And I knew how to do spreadsheets as a kid, so that is actually quite feasible with a spreadsheet. Well, still, I'm not really sure how I do it with a spreadsheet. I know you can do formulae in spreadsheets which make absolute references or relative references. I don't really know exactly the right terminology to make that, but it's probably doable if you know how to do spreadsheets. Okay, so okay. So we just do this until we get to that row column, and then we're done. So it would be an infinite loop, which executes. Okay, so yeah, I don't anticipate any blocking issue here. I think I just have to write it all out, and it should just work. So let's say table equals a dictionary, and table. Okay, let's set the initial value. So it'll be row. So the term, what they're using is row 1, column 1. Do we want to start from 0 or 1? It depends on, it doesn't really matter, but I would say. So then we go to, so we can do that, then that, then that. If we go to this one, we use, doesn't actually matter. We'll copy what they're doing. So row 1, column 1. Okay, 1, 1 maps to and the 2981, okay. solution equals 2981 3075. That's what we want. So we want while true, let's say row equals, let's say row column equals the next thing we want is so row 1 column 2. Okay, so while true, so we want to find, we've given a row and we're given a column, and we want to find what number that is. So if we're in the bottom right, i.e. we're in row 1, we have to find out what the previous diagonal had. Otherwise, we simply use what is down and to the left of us. So those are the two calculations, possible branches we have to make. So if row, not row, column, if column is 1. So this is the outlier. So if we're in column 1, we need if we swap our row and column, that gives us the symmetric version, which is up and to the right, and then take 1 from the row. So we want to take prev equals, so the row will be 1, the column will be row minus 1. All right, I'm getting these mixed up. Row, column, no, this should be 2, 1. We want to find row 2, column 1 now. All right, while true, if column is 1, then the previous thing we look at is going to be row 1, column R minus 1. So row 1, column R would be the triangular item, which is kind of reflected in the diagonal. So it'll be the top right one. And if we subtract 1 from the row, from the column, that moves it to the left by 1. So I think that is the item we want. Otherwise, we just want the one which is down and to the left. So it'll be row plus 1, column minus 1. We declared prev defined above without usage. Yeah, well, okay. So new value equals, so we take the table value of prev, multiply by, so what was it? Another reason to use Python, because we're using big ints now, and then keeping the remainder from dividing that value by this. So we do we set table of R c equals the prev times that, mod out that, and that'll fill table, right? We also want to check if we've reached the goal. If RC equals solution, break out of this loop. Is that it? Don't see any problem here, because it'll start with the top left, and then it'll go down by 1, upright, and then it'll go down to the next row, upright, upright, and go down. I think that's it. And then we print table. So yeah, it is something you have to really get your head around, but then, all right, let's see if it actually works though. All right, now it's gonna take a long time. It's going to go into the millions. I should have printed some progress meter. If we could print every row and column that are multiple of 100, that would help. Yeah, I would like to see the progress here. If R%100 equals 0 and R% and C%100 equals 0, print RC. Okay, go. Whoa, we're not even reaching that. Oh, I know what's wrong. Yeah, this is very bad. We're not changing RNC, we're literally just using 2-1 over and over again. The last thing we need to do is change RC to be the next one, so now we change, just write a note here, iterate to next RC values. So basically the opposite of this, we're trying to find the next. So if, okay, so it's the same principle. If R is 1, then the next thing we want is like that. Else we just do row -1 and C +1. That goes up, right? That's just the inverse of this thing. All right, try that. All right, that's fine. Slowing down a bit, but there we go. Is that gonna be right? It's gotta be right. Yes! I mean, it's hard to say whether I think that problem is hard or not. It's like, there's definitely a moment where you have to have all your brain power on at 100%, but only for a fleeting moment. It's just one of those problems. And part 2. I was wondering if they were actually going to have a separate part 2, but it is as tradition. Okay, the machine springs to life, then falls silent again. It beeps. Insufficient fuel, the console reads. 50 stars are required before proceeding. 1 star is available. 1 star is available? You check the fuel tank. Sure enough, a lone star sits at the bottom, awaiting its friends. Looks like you need to provide 49 yourself. You have enough stars to start the weather machine. Should we do it? Like, we shouldn't really mess with the weather. This is actually kind of bad. We shouldn't just force snow on the world. That could have devastating effects. That is basically kind of like butterfly effect. It could cause hurricanes in some parts of the world. But it's Christmas, so... You fill the weather machine with 50 stars. It comes to life. Snow begins to fall. Congratulations, you've finished every puzzle in Advent of Code 2015. I hope you had as much fun solving them as I had making them for you. I'd love to hear about your adventure. You can get in touch with me via contact info on my website or through Twitter. So, by the way, this is the guy behind this is Eric Wastel. He actually stopped by my chat once while I was doing Advent of Code 2022. He popped by in Twitch, so he's actually he watches people doing these on Twitch, and he likes to drop in. So, okay, if you'd like to see more things like this in the future, please consider supporting Advent of Code. Yeah, this has been going strong since 2015, and it's only been more and more popular every year. Like, a lot of people, you know, coders and beginners alike, like to take part in it. It's very much a community. I would say at this point, it's now the most popular community coding thing. Like, there's a lot of websites which used to be popular, but they're all shutting down because they're not financially viable anymore. I think there's been a decline in interest in these types of things, but, you know, clearly Eric is putting in a lot of his own time to do this and not necessarily making any money out of it. A lot of those other companies have actually had to shut down their competitions. Google, I got an email recently. Google has shut down their Google Code Jam, which for the last decade or so has been one of the most popular coding competitions. And they're saying their last Google Code Jam will be this month, which is sad. But this one's still going. And it's not as high budget as Google's Code Jam. You'd have thought Google would have enough money to keep the Code Jam running, but apparently not. So, Google Code Jam was what actually introduced me to coding, in a way. But I'm happy to see that there's still something still going. All right. I've highlighted the Easter eggs in each puzzle, just in case you missed any. Okay, so now what happens is he unlocks lots of Easter eggs. Oh, and we filled in the tree, and there's an animation. That's nice. Oh, those are the reindeer, are they? Pretty cool. Now, if you go back to the problems, he now puts in lots of Easter eggs, which are highlighted red. Okay, does that actually appear on stream? So the highlight here says, also some puzzles contain Easter eggs, like this one. Yes, I know it's not traditional to do advent calendars for Easter. Any others? Not on this one. Problem 2. Oh, it doesn't. Yeah, it's not going to appear on stream unless I were to do display capture. I won't bother reading them out on stream, but just have a look. What's this one? So this was the problem with the cuboid volume. Man, so long ago. So all numbers in the elves list are in feet. And the highlight says, yes, I realize most of these presents are luxury yachts. I was pointing out, yeah, back then that these numbers were pretty big. These are pretty big presents. Good stuff. All right. Well, my private leaderboard, which anyone who's watching can join if they want to, is this one. These were 2 viewers who stopped by. It does this for every calendar year. So I've now completed 2015, 2020, and 2022. So next time I'll come back with 2016. It probably won't be long. Like I thought 2015 would take me much longer than it did take me, because I was comparing with the recent calendar years, which were actually much harder and took much longer. And clearly Eric exposed himself to some really smart coding and mathematical ideas, which he incorporated into these problems, which made them harder overall, which is great. But 2015, that didn't take that long, and most of the problems were actually pretty textbooky and straightforward. So it only gets harder from here. So I don't know when I'll jump into this. Probably in a matter of weeks, because I don't feel exhausted yet, like I did after 2022. Yeah, I could feasibly jump into 2016 pretty soon, so I could probably do that in a week or two. But yeah, I mean, I don't know if I'll be... Okay, I think it's realistic that I could complete all these years before the actual 2023 happens, which will happen this year. Just depends how long they take me. So yeah, hope that is an inspiration to some, especially those who don't code. This probably has given some insight into what code can let you do. And I mean, the beauty of Python is that it's so readable that even people who don't code can look at Python code and actually understand what it's doing. Like I've definitely had lots of people tell me that. Python is known for that quality. Compared with like C++ or something, Python is way more readable to someone who doesn't understand code, because it is very natural language like, but it doesn't sacrifice power to do so. It is still a very powerful language, and clearly I was able to deal with big integers, which you can't do easily in Java or C++. You have to have a custom class or something. Yeah, exactly. That's why Python is so great, but also, yeah, as I said, it doesn't sacrifice power to do it, because there are some problems which I wouldn't dream of doing in anything other than Python, because Python has some string handling methods which other languages don't have. It has big integer support, which is good. It has JSON handling. So JSON is something that non-coders sometimes may come across. JSON is where you have databases for like a file, which is .json, and it's literally just like a set of key value pairs or lists and stuff like that. People who work with databases who don't do coding probably use JSON. Some of our Azadreams tools use JSON. Like Chai and Programmer both made tools which export, like the map that Azadreams runs on to JSON, so you could configure it in JSON without needing any coding and make your own Azadreams maps. State Display uses JSON, yeah, exactly. For the it's a database I say language. It's not really a language. Well, it's debatable what the word language means. Some people say for something to be a language, you have to be able to write loops, and you can't do that in JSON. JSON just expresses a database, but it doesn't actually go into any loops. But people call HTML a language, and you can't do loops in that either. So, but yeah, Python, you can open a JSON file using import JSON, and boom, you've got the JSON. If you were using something else, either you'd have to find some JSON module or you'd have to write something yourself. So Python and JavaScript both share that in common. They're very JSON friendly. And some of these problems were, which was it? There were a couple of problems which were, it was basically JSON format. I mean, look, this is a string problem. And as soon as you're using strings, as soon as you're cutting them, trimming them, taking pieces and moving them around in the strings, you want to use Python, really. Because Python, you can write very natural string handling methods. Like you can say, if I want to see if the sequence AE is in that string, I would say if AE in string. I would write it like that. You want to do it in C++, you're going to have for int I equals 0 from I less than length of string I++. That's just the opening of the loop. And then you'd have to say if string I equals A and string I plus 1 equals E, break out of the loop. You'd have to write something like that. And that can be condensed in Python to if AE in string. It's like beautiful. I mean, people use C++ because it is technically faster, and that horribly long-winded way of writing it is technically better if you're writing robust software, but we're not doing that, are we? So that being said, Python is moving towards something people are actually using for software, so it's only getting better. I mean, that bookless tracker that you guys may have seen that I made, that was written in Python. It didn't need to be fast because it only updates every time you click button, so it doesn't need to update several times per second or anything like that. I don't know how often Chai's tracker updates, but even that might only be once every half a second or something, so it doesn't need high computational power. I don't know what Chai used for his. Okay. I just want to keep it on this screen and then my calendar. And every now and then you do come across a problem you can solve by hand, and that's always fun. And the craziest one, I think the one that most people were most talking about last year, was the one where you kind of, the way to solve it really was you had to actually take a piece of paper in real life, make a cube template, cut it out and fold it into a cube. And that really helped you know how to match the edges, because it was basically the problem involved a huge cube, and walking around on the surface of the cube. And you had to walk from one edge to the other, but it wasn't clear which side you'd end up with unless you actually make this cube and hold it. So after people solved that problem, everyone was posting their photos of their cubes on Reddit, which was pretty funny. State display refresh faster than once a second, but don't remember the fraction. Yeah, unless you're getting into like the 60 frames per second territory, then you never really need to use any powerful languages, I would say. You never need to write it in C. Which one was the cube? I think it was 15. Yeah, this is the one. No, this is not the one. 16? Alright, it doesn't matter. It's somewhere in there. Alright. Yeah, I'm glad I found Advent of Code, because there's not many things I think out there are kind of streamable. Like, some of them are a bit, I don't know, esoteric, a bit not something you really want to stream. They're a bit they're like 2-hour competitions and they're not really stream friendly. This one is relaxed. It's like one problem a day, go at your own pace. The other one I normally stream is this one, Coding Game, but they've reduced the number of competitions they have per year. It might be a budget problem. As I said, a lot of these companies no longer have the funds to support doing these events because I guess no one's giving them the money anymore. Interest in these things is dwindling. But they have one which is tonight, but it's not, I can't stream that. That's not allowed for this particular competition. But later in the year, they have the one which I do, which is like AI, where you write your AI bot, and that takes a week, and you can stream that. But that's going to be in the fall. Autumn, as we call it. All right, well, that's it. I'm done. I gotta go cook food now. So thanks for watching. And I'll be back with this probably in a week or two, because I'll probably be dying to get back into it because I don't think I'm done coding yet. All right, see you next time. And I will put all these videos up on YouTube as well, so they'll all be there.